Okay, welcome to Mr. Sou's Math World. So today we continue to discuss the differentiation for logarithmic function. So please go to page 4.7. So last time we have go through example 4.12. So right now we going to discuss 4.13 and 4.14. So this part, the most important point is to understand how to use the log for differentiation. Okay? So when we use it, we will basically follow it with chain rule. For chain rule, it means the step like this. So let me copy the question. So when we have chain rule, step 1, we will have log d, the logarithmic function. Okay? So this is step 1. And step 2 is we will differentiate with respect to x. Okay? So let me write down the detailed step for you. Okay. So for the first time, I show you the steps on how to write it step by step by using substitution. Okay? So we will use everything inside the bracket to do the substitution. Okay? So you can differentiate with respect to x. So I think this part, all of you understand how to do. You get 10x here. And you differentiate y with respect to u. Log u becomes 1 over u. Okay? So if I want to find dy dx, that means we have dy du by using chain rule times du dx. Okay, so dy du is 1 over u. Du dx is 10x. So after that, substitute the value of u. Okay, you get 1 over 5x squared plus 4 and multiply by 10x. For this one, it is not simplified because this is in the middle of fraction, which is not accepted as final answer. Okay, so if you want to get final answer, put it in the upper part, that means the numerator. Okay, so this is the way to handle. Step 1. Let u to be the things to be used for chain rule, and then let y to be log u and differentiate with respect to u. Okay, step 2, use the chain rule to do the differentiation and then substitute back the x to get the final answer. So let's go to part B. So this time it is a little bit different from part A. Because in part B, you have one layer more. Part A, you get only the u let to be this one, just like x plus 2, and then it is done. But for part B, you have power 6. But this power 6, we don't have other formula for it. So we need to let the other function to calculate for log x plus 2. So let me show you how to do. So you can see that I've let u to be the whole thing here, log x plus 2, and then 3 will be the thing inside x plus 2 only. Okay, so that y will becomes u to the power 6. Okay, so you may wonder how to use the chain rule. So it is very sure that we will use dy to with respect to du. Okay, so 6 times u to the power 5 is for sure. Okay, so we need to make sure how to handle for the chain rule. Okay, so for chain rule, we are doing by layer to layer until you can get dx. So dy dx, we will have dy du, and then d something, and then d something dx. Okay, so these two must be the same, but if you're having chain rule. Okay, so this is du. That means it is the middle layer. Okay, so for du, you want to focus it to handle until dx here. Then that means we need to have of v. Okay, so we use dv. So dv here. Okay, so we have 3 parts. Alright? Okay, so that means this one we should put it to be u equals to log v. And then we differentiate it with respect to v. So you have 1 over v. Okay. So in the middle part, that means dv dx, you only get 1. Alright? So this is the very important part. Basically, you have to understand how to link up them pairs by pairs. Okay, so finally, we can go to the step here. Put it as a part of step of chain rule that you get the answer. Okay, so dy, therefore, dx. So the first one is dy du. So dy du is 6 times u to the power 5, step 1. And then you get multiply the middle part, du dv, 1 over v. And then finally, multiply by dv dx. Substitute back, so 6 times log x plus 2 to the power 5, and then divided by v. So v is x plus 2. No need to write plus 1. So this is a simplified answer for part B. Okay, so this one you have more than 1 layer to do the calculation, and this is actually quite difficult to do so, right? So make sure you can do it 1 by 1 and do not skip any step. So this is the most important clue for it. Okay, so we'll go through similar question in the lesson this Friday for part B, especially in part B. Okay, so this is the final question I want to discuss in this part. Alright, okay, so this one is still about natural law. Okay, and then this one, it looks even more difficult than before, but no need to worry, because this one, the focus is to simplify the expression before differentiating it. So look at the question carefully. In the question, you are given this part. The square root 3, this one. The cube root, okay? So for this cube root, if you remember the way to handle, we know that this one can be put outside the logarithm. Okay, cube root, power 1 over 3. Put it in front of the log. Alright, okay, so when we want to differentiate, this one will be much easier than before. Okay, so let me write down the rough right here. So you get u to be x cubed plus x squared minus 5x plus x. Okay, then if I differentiate it to be 3x squared plus 2x and then minus 5. So after we have done so, then you can weigh out carefully, okay? So differentiate dy dx. So 1 over 3 multiply the things we're going to differentiate. So step 1. So remember, this one we can change it to anything. So this time if you say, I say the u here, and you also get y equals to 1 over 3 log u. Okay, then if we differentiate it with respect to u, then you get this is 1 over 3 times 1 over u. Okay, so 1 over u means 1 over x cubed plus x squared minus 5x plus x. Okay, and then after that, multiply by du dx. That means, put a dot here, 3x squared plus 2x minus 5. Alright, okay. So you see that there is no common factor to be cancelled out with 3. Okay, then put the thing here. On the upper part. So in this question, you see that if we are able to simplify the thing before we do the differentiation, you can obviously save lots of time. Okay? So remember the clue and get everything systematical and do not skip any steps. So that's the end of Mr. Sou's Math World. See you next time.